Thank you everyone for joining us right after lunch. So we'll make sure you can take a nice nap. You can just relax, close your eyes. No, please don't. Welcome to our talk. We'll talk about what an inner dev loop is, what an outer dev loop is, and how do you take your code from one to the other, and how you can do that in the Databricks Workspace and use this thing called Databricks Asset Bundles. So we're very, very excited to have you here. But first, some introductions. Let me get the mouse over. All right, I'm Saad. I'm a product manager on the developer ecosystem team. And what we work on is all the ways that you can interact with the product that's outside the product. So things like your SDKs, IDEs, CLI, CICD. Before that, I was CTO, co-founder at Connectera, where we were making Fitbit for cows. And cows we will talk about a little bit later. Nicole?
Yeah, my name is Nicole Liu. I'm the product manager for Git connectivity and productionization in the Databricks Workspace. Super excited to be here. My team is responsible for Git folders and adding more Databricks assets into source control. So before I became a product manager at Databricks, I manage the contents of industry solution accelerators at Databricks, which is a list of industry problems with solutions that are written on Databricks. My job back then was to host the contents and make sure that they can run end-to-end in the user's environment when the user wants to try them out. And of course, I hosted my contents on Git, and I had to build CICD for the contents. Back then, this was before Saad's team built Databricks Asset Bundles. I had to create API-based tooling, which I believe a lot of you all in the audience may have also done at some point. And that was really painful. So I'm really excited today to show how the CI/CD lifecycle now looks like with DAB and how to do that directly from the workspace.
All right, so let's get into it. We get a lot of feedback from you guys, our customers, about what challenges you have when you take a proof of concept and try to productionize it. And typically for each one of these, there is some sort of a best practice, some technique, some pattern that you can implement to get out of this. So if I make edits on Nicole's notebooks, I might break it, I might clobber her changes, or worse yet, I could do that in prod. So what do you want to do? You want to isolate your copies, your dev copies and your prod copies. How do you know if it's going to work? Well, you want to be able to stage your changes, test them, and validate that it's going to work before you actually deploy them. You spend a lot of time on finding issues. You want debugability. You want to be able to explore all the variables. You want to be able to find out, just step through your code. Sometimes you end up repeating the same piece of code over and over again. That might sound familiar. In software best practices, we call this thing, don't repeat yourself. So write a library, write some shared code that you can share with the rest of the team, but you want to be able to refactor your code. And I've done this many times in prod, like just a small change. It's best not to tempt fate. You should automate. I worked on that all night, so there we go. But yeah, just automate your workloads and your deployments. And then finally, you want to be able to trace who changed what and when, and maybe even why. And for that, for that auditability, for that traceability, you want to have some sort of version control. So thankfully, this is not a new problem. Decades of software engineering has given us these best practices. We'll just do a quick intro on what they are, because I kind of struggled with it initially myself. First step, get your dev environment ready. If you're in IDE, in the workspace, might be a notebook, step number one. Then set up source control. Code base, small, large. This is a really good way to scale what you're doing. And then you want to make sure that, the way you lay out your project structure, you may have organizational standards, how your tests are scaffolded, where your fixtures are, set that up. And that starts this inner dev loop, where basically you're authoring code, and you're testing and maybe finding issues, debugging them, refactoring them. And then once you're confident that your changes are going to work, you kick it forward into the outer loop with maybe a pull request, and that starts your continuous integration and deployment, also known as CICD. So, and then you start all over again when you have a bug or you have some sort of a challenge or a new feature that you want to add. So I mentioned that there will be cows, so here they are. My company, we made Fitbit for cows, so using artificial intelligence to improve animal welfare, productivity, and sustainability. But then I read this book, which basically shows that cows are very social creatures and they make friends. So I was like, okay, let's take some of the sensor data and maybe prove a hypothesis, which is if cows are best friends, do they take their meals together? So that's the thing that we're going to explore today. We had to find something to keep you guys awake after lunch, so we went with cows. So basically, we have this time series data where cows are just, you know when their start and end times are. And you find the overlap, and hopefully you can get to a point where you have these best friends that are available and visible, sorry. So I'm going to just quickly go over to our data. And I had a job here that Nicole helped me author. And so, yeah, it's fairly straightforward. I read my data. As I said, I love these names, by the way. You know, they're non-denominational. I want to make sure they're not named after a person, unless you're butterscotch or cocoa or mocha or marshmallow. I apologize. Any similarity is purely coincidental. So we have cow meal data, and then thank you, ChatGPT. I got some fancy code to tell me how to calculate some overlap. So I did some magic here. And then a heat map should hopefully show me where my best friends are. So this looks really cool, but it's wrong. And I think, Nicole, I'm going to need some help to fix this. So maybe you can take over control and dig me out of this one.
Yeah. Why does this look wrong? Does it look wrong because it's all just orange everywhere, that there's no clear pairs of friends that you already know?
Yeah, it's a heat map, so I was expecting. I know there are two best friends in here, so it should have been lit up like a Christmas tree, but it's not, so.
Yeah. Okay, let me take a look. So first of all, I will go to the notebook where this job is run on top of. And immediately, is it big enough for everyone to see? Should I zoom in?
Zoom in, or is it fine?
Zoom in.
Zoom it in.
Zoom it in.
The crowd has spoken.
Cool. Awesome. And you notice that this doesn't have a branch button here that tells me that this is not in source control. So when you have code that's not in source control, it's harder to isolate your version with a production version. It's also harder to track who did the change and when. So the first thing I would do before even going in to fix the problem is to move the notebook into source control. And I would do that by simply moving the notebook into a Git folder. So Git folders, if you're familiar with repos, Git folders work very similarly to repos. They're just the modernization of repos that now allows you to have Git folders anywhere in the workspace. And we're also working on adding more assets into a Git folder. Assets that are coming up include DB SQL queries and Lakeview dashboards. So I will simply clone this notebook into a Git folder that I've already prepared, and that has a folder structure that I would like to use. And I go to my new Git folder, and here we are. You see that there's a branch button that indicates the branch it is on, so this notebook is now in source control. What else may we need to source control? So I didn't mention this one earlier, but by investigating the cluster, I know that there are some libraries that are defined as cluster libraries. They may be necessary for the code to run end-to-end. So in order for the code to be reproducible, we should capture those dependencies. And the best way to do this is to do it as a requirement.txt file directly in the repo. Oops, sorry. I'll type in the name, requirements.txt, and then I will paste that. Oops. I'll paste my requirements into the requirements file. And lastly, I will also add a pip command to the beginning of the notebook to indicate that my notebook has this environment specified. So, okay. Let me run this end to end. It will re-execute, and it should display the same heat map as here. All right, so we've reproduced the results. Let me commit the notebook and environment. Great, our notebook and environment is now in source control. Now let me unpack and peel the onion a little bit. So we know that Databricks notebooks have visualization capabilities. One of the ways to really quickly validate if this visualization itself is broken is simply to reproduce it using our notebook visualization. So I'll just do that quickly as a way to validate if there is an issue just in this visualization. I'll add a heat map by going into visualization type, select the heat map, select the right columns, and boom, we have a visualization. It does show the same pattern even if the color is different, so we know that the visualization code itself is not the issue. So I scroll back a bit more and see what else is in this pipeline. We notice that right after reading data, we have this very long block of code. And looking at this combines both the definition of the UDFs, the user-defined functions, and the calling of those UDFs. So this is an approach that we see often, but it has some serious drawbacks. Because the way it's not modularized, it's harder to reuse or to test this UDF. So what we want to do is to modularize this logic into a Python file, and then you'll be able to import that into the notebook. I have a version that I can show you after having done this refactoring, and I will show you here now. After some refactoring, we now have a new version of this notebook that just simply imports from another Python module. We can go to that Python module and take a look. Since we know that something must have been funky in this Python module. So you see a Python file. This is a Python file in the workspace. What you can do with it, you can run it end to end. You can also debug the file by running this line by line. You can see how the variables values change over time. So in addition, you can set breakpoints. So here I wanted to run a manual test for a pair of examples that I know the results of. So if I have a cow that starts eating at the 0th minute, ends at 20, I have another cow that starts eating at the 10th and ends at the 30th. I know the overlap should be 10. So let me debug this. You see the variable explorer showed up. When I step in, you can see the values start changing. When I step into a function, you can also see the internal values of within that function. And then if I just complete the execution, I see the overlap is 30. So there must be something wrong with this overlap calculation. Before I fix this, I do want to show how to implement some testing so that this kind of issue can be caught in the future if someone else messes it up again. So with testing, we're showing an example using PyTest. The structure should be familiar if you're familiar with PyTest. All I do here is adding our test case here and then 2 other test cases. I can show how the PyTest will be triggered from within the workspace. So in this example, I'm just using a notebook as the entry point of the PyTest. This is boilerplate code. You shouldn't have to modify too much from this notebook. And what it does is simply calling PyTest. Okay, our test is running. And as we expected, this failed. So now let's go back to our module, try to find the problem. Looking at our overlap function, it doesn't seem like it's trying to calculate overlap. So in order to calculate overlap, it should take the min of the ends and the max of the starts. And after doing this fix, let me go back to running my test again from our testing notebook. Okay, our simple unit test for the UDF has passed. But you may ask, well, what about the rest of the data frame transformation logic? Can we have a test for that as well? And of course we can. So I will go to a version of the test that I included some tests for Spark code. A few tricks here. One is just to set up a PyTest fixture for your Spark session. There are some details about Databricks Connect here. So there was a talk on the same subject last year that touches on this topic a lot. If you have any questions about Databricks Connect, you can refer back to last year's session. There's a lot more information there. But this is something that can be useful whenever you need to test Spark code as a unit test. So the rest of the test is fairly simple. It captures the input data frame directly in code. Alternatively, you can also read from a CSV or some sort of file directly in your repo. As long as that file is not too big, that shouldn't be an issue. And then we just assert the expected output matches the result. Okay, let's run our test again. All right, our test started. The UDF test has passed. Okay, cool. The Spark test also passed, despite some warnings. All right, so up to here, we have been able to test our notebook, test the modules, and this concludes the inner test loop. But remember that we have also a job, our simple notebook job, that what about the rest of the job configurations? Is there any way that we can also source control that as well?
All right, we'll look at that in a minute. Thank you, Nicole. This is the last time I'll trust AI to write my code, so I guess our jobs are safe for now. So what Nicole basically showed was some simple, there we go. So we put our stuff in Git so we can source control it. We refactored our code, we debugged it, and we tested it. So let's just jump ahead. So we were in the inner dev loop, and now we're going to transition over to the outer dev loop. Just a show of hands, how many people here are familiar with Databricks Asset Bundles? Okay, that is, thank you. That's quite a few people, excellent. So we'll start with why. Why do you need it? And then we'll talk about what it is. It's basically you want to be able to bundle together your project assets. So things like your notebooks, your jobs, your pipelines, anything that you can author, you want to express it as code or config. So you can co-version it, you can co-author it, you can co-test it, you can co-deploy it, and it functions as this unit. And that really helps you kind of enable these best practices, these software best practices that we've been talking about. That allows you to isolate your environment. So I can set up my dev copy, Nicole can set up her dev copy, we can have a production copy, so we have this isolation, the sandboxing. You don't want to have manual touches, so you can have automation actually take these configurations and materialize them across your environments. And then you're not fire drilling in prod, which is always a good thing. As I mentioned, you're writing a consistent configuration once. You can have some overrides, but you're basically writing it once so you can deploy it everywhere. All of this allows you to make your deployments repeatable. You can make them auditable. So what are these? And we lovingly call it dabs or bundles. So if that's a moniker that you've heard, it's the same thing. And it's, what is it? So it's basically a declarative format to describe all of what I just said. Your project configuration, your code, and we just express it as YAML. And you have the ability to not just specify your configuration, you can override depending on which environment you are. You don't want your jobs in dev to be scheduled, right? You just want to run them. Or you don't want your jobs in production to have multiple copies running. So you can specify some of those overrides. You can be as coarse-grained, as granular on your permissions as you want. So you can specify who can access what. And who can do what. And then you also have the ability to write modular code within this infrastructure, so you can have references and lookups. And a really nice feature that we have is the ability to create or to build and deploy your shared code, like as Python wheels as part of your project. So you don't have to go create copies of that code, but just specify it once. And just include that library it builds as part of the deployment. And this package is delivered, the delivery mechanism is the Databricks CLI. And there's a number of talks that we've done on that, but it's something that we've written from scratch. It's built on top of our Go SDK, which is built on top of the entire API specification of the Databricks API surface. And automated to your heart's content, whether you're using some sort of DIY or using some GitHub Actions, Azure DevOps, Jenkins, what have you. So we'll talk a little bit about that. And I think there's a video here which describes the YAML file, but Nicole is actually going to take us through this. But like any good software picture, which goes from left to right, this is kind of the canonical, how do you get stuff from dev to prod picture. So you start at the left. You're writing your code, you're in your sandbox, you test your code, and once you're ready, you commit it and start a pull request that starts it in staging. That deploys your project, runs it within that workspace, and then once Nicole is okay with the changes that I've made and the tests are passing, and we merge it with the release branch, gets deployed into production. So this tagline, write it once, deployed everywhere, that kind of becomes true at this stage with Databricks Asset Bundles. So Nicole, maybe you can take over and give us a little preview of how we do this in the workspace.
Yes, I'll show you what the dab of our simple job looks like. Okay, here's our dab. The entry point of a dab is this databricks.yaml file. It includes the target environments that we wanted to develop QA and productionize in. You may notice that some of them have a workspace attached, some of them don't. I'll get into that a little bit later. There are also variables that you can use to override the default variables defined in the resources. The resources are files that describe your jobs, your DLT pipelines. We typically keep it organized by writing one file per asset. And this is our simple job, or the resource for our simple job. It may look like a lot of boilerplate to write, but in fact, you can get 80% of this by going into the jobs homepage and then simply copy from the jobs YAML. The jobs YAML may include some optional values that are not included in our version in the DAB, but it mostly describes the same thing. You may have to do some editing, such as to change the notebook path. And this is an area that we are developing to better support visual editing of YAML files directly in the workspace. So bear with this copy pasting for now for a bit, and we will make this better. And now that you have both serialization of the notebooks and the DAB, what can you do with it? So you can validate and deploy and run a DAB. So the way to do this that I will show today is to do it from within the workspace. So I have a placeholder notebook just to pop up my web terminal. I will use the notebook web terminal to deploy the DAB. First, let me switch into the current directory. This DAB should be omitted coming out fairly soon. We're doing work to make this automatic. So now that I'm in my current directory with the DAB, all I need to do is type Databricks bundle deploy. This is the part of the demo that's the newest. So full transparency, I'm using a special build for the CLI. And this feature will be available in the official CLI within the next month. So it will take a few seconds to deploy the resources, and it will be deployed into the current workspace. And you notice that I haven't had to specify which workspace I'm in, and I'm directly starting to use the CLI without having to authenticate myself. That's because I'm using the web terminal. Databricks already knows who I am and which workspace I'm in. So that's the benefit of specifying a development mode in the Databricks in the bundle config on the previous page. So our deployment has completed, and we can take a look at our jobs, and you see a dev job that was deployed, and it shows that it's connected to the asset bundle. And it has our single notebook task. And what we've just done as a recap was that we were able to capture the code, the configuration for the job in source control, and we were able to deploy it from the CLI. And that formed the basis of CICD. So can we do this along with triggering unit tests automatically when a PR is created or a PR is merged? Of course we can. So that's our CI/CD step. So we're finally getting to the stage where we can do some CI/CD. So the incremental part in this stage is just that we added some GitHub action workflows. So we have two GitHub action workflows. We have one workflow for validate, where it runs in a staging environment, and then it gets triggered when there's a PR that gets opened or synchronized to one of our main branches. You can run a unit test and bundle deploy into the QA environment. And then the other GitHub action is the deployed action, which gets triggered when the PR is merged. And it does similar steps of unit testing and deploying, but deploying to the prod environment. So let's try making a commit. So I've just done some simple changes to be able to commit and create a PR. I can then open a pull request.
Can you zoom in?
Yes, I will totally zoom in. All right, Here's my pull request. And the deployment gets triggered, or the validation gets triggered. So this is our CI GitHub action that does the unit test and deploys into the QA environment. It will take a few minutes, so I will show you some history of the GitHub action for the other CD pipeline. You see, I have some history here. This action was triggered when the PR was merged. And we can see the deployed results. Notice that this is in a different environment. This is my production environment. I'll zoom in as well. This is my production environment. The job is deployed by my service principal. So this is not my user doing the deployment. This is a service principal that gets triggered from the GitHub action. So the deployment automatically captures the repository URL as well as the branch. And you can see that there has been a few deployments happening in the past. All those deployments happen and update the same job so that you can have a continuation of history within the same job ID. Cool. So that concludes our CI/CD journey.
Okay. Well, we don't know who our best friends are, Nicole. Maybe we can open up the job and see, because I am curious. Let's see. I know we didn't rehearse this part, but it should work. Where is it?
Yeah.
There we go. So we have, yay! Mocha and Coco are the best friends. Thank you, Nicole. All right, so let's get back to our slides. So to recap, I'm just going to use the same infinity rings to kind of anchor what we talked about. So we talked about source control and setting up your dev environment. That was our Git folders and dabs that Nicole showed right up front. Then in your inner dev loop, we were using notebooks and writing pure Python code. And that was in the Workspace file system. We were using PyTest to do some automation of our testing. And then you saw variable inspection, step-through debugging, all of these capabilities available inside your notebook. And with the peer request, she triggered our CICD, which was basically using GitHub Actions. You saw the Databricks CLI, and there was some Databricks Connect in there for good measure. So basically, the nice thing about this is it brings the whole story together. And obviously, there's a little bit of, let's say, YAML editing. It was not as clean as we'd like it to be. So we're actually going to be building an experience for dabs within the workspace, a more native visual editing kind of an experience. And we'll talk a little bit about that in the Q&A section, I hope. And so that's going to be available in the coming months. We're still working on it right now. Dabs, we have a Python SDK for it as well, which is actually in private preview. So if you would like to work on it or just give us some feedback, please let us know. It's built on the same thing. So if you've already started adopting dabs, it's just like a Python representation of the same deployment. Underneath, it's the same dab. And then we'll start the Git coverage continues to increase. So we're adding DB-SQL and Lakeview or AIBI dashboards. Yeah,
sorry.
That's the name. And we'll be dabifying it as well. That's now a verb, so I'm going to stick with that. And then just to sort of round off like our developer experience, we've got PyCharm integration for the IDE as well that's available. Our partners at JetBrains have helped build that. And then there's a bunch of talks that we're doing on the developer ecosystem team. My colleagues sitting at the back, Teresa, Peter, Fabian, who've talked about IDEs and dev tools and actually dabs. We'll have the dabs talk later today twice. So not once, but twice. So hopefully you guys will come attend that. And we'll be outside if you have any more questions. Thank you.